Okay, we are back. AtCoder starts in 2 seconds. I forgot to change the text here. AtCoder, let me just solve the first 2 problems really quickly. So check out other videos on my channel, and thank you guys so much for tuning in. Job interview, you're given and the number of interviewers. And S of like the evaluation, corresponds means good, fair, or poor. Takahashi will pass if both of the following conditions are satisfied and fail otherwise. At least one interviewer's evaluation is good, no interviewer's evaluation is poor. So, okay, so let's solve this. Yeah, thank you guys so much for tuning in. The last couple of videos are good. There is this square root decomposition on trees video, which you can guys check out. Tell me guys in the comments what should you if S of I, how is good? Tell me in the comments what should I actually, what kind of videos should I make? Okay, if this, then yes, otherwise no. I'm a little bit late, that's why. Okay, you are given n by n matrices where each element 0 or 1. Let AI AJ denote BJ denote the element. Okay, determine whether it's possible to rotate A so that for every pair IJ simultaneously so what kind of rotation is this? This is it's like a 90 degrees rotation. Is it a 90 degrees rotation? Okay, so this is A. And 3N, what am I doing here? Okay, and then I will do 4 rotations. First I will check and I need to read B as well, so let me just read B. I will check. So this is rotation. Let's see. should zoom in probably. If this is not equal to bj, then okay, it's false. If it's not okay, if it is okay, then we see out yes, return. And here we rotate, we say A is rotate of A, and then okay, let's rotate matrix. Rotate of A, and N. What is the rotation here? Is it 90 degrees or? It's 90 degrees counterclockwise, right? Well, this is not yes. How is this yes? Oh, yeah. It's not exact match. It's just if it's for every pair integer side j sometimes determine whether so that bj for every pair if aj if it's aj and it's not and bj is 0. If it's aj and bj is 0, then that should be it. Okay, let me just fix the AtCoders. What contests are we in? 8. Okay, now we're getting into. Okay, we got AC on A and B. We have n boxes that are initially empty, unlimited number of blank cards, queue queries. IJ, write the number I on a blank card and put it in the box J. Report all numbers written on the cards in the box I. Report all box numbers of the boxes that contain with a card with the number I. Okay, so two kind of data structures. what is now there are n boxes. N can go to what? N can go up to. So there are n boxes. Each of them is a set. And then there are Q queries. Okay, for each query we have a type of the query. If type is 1, then we ing and we say write the number I on a blank card and put it in a box J. So boxes at J dot insert. Oh, can it be? You have a multiset, probably yes. So I'll just say that this is a multiset. And then you have to also add to something report all box numbers of the boxes that contain the number I. And the number I is up to 10 to the 5. All boxes that contain the number I. So contain at I.insert J. And then I need to report for auto element in what numbers of the cards in box I, boxes I, elements. And else this is type 2, else for report all boxes, all the number of boxes contain now if I should plus 1 here as well. Okay, this passes. Okay. D, we have a string which is initially 1, process the Q queries format, append a digit X at the end of the string, delete digit at the beginning, print the number represented by S in decimal modulo this. Okay, okay, this is kind of easy because if we append at the end of the string, what we're doing is we're times that plus something, times 10 plus something. If we delete at the beginning of the string, what we do is we first have to we can do binary exponentiation. So it's initially 1, right? So modint, just is this the same module first? Let me check. Yes. And there are 2 queries. Each query in type, if type is 1, 2, else type is 3, I will just see out s. If type is 1, I will s times 10s plus some digits. So if type is 2, I will say also I would have to make a queue of these digits as well. Push this digit and the queue is 1. And now I will need to from s subtract power of 10 to the power of 10 to the power of the q dot size minus 1, q dot pop, this power times q dot front. This power gives me, okay, I think this should pass. Let's go. Okay, passes. Let me just see the standings while we're at it. Unfair. Okay, this is probability problem. Okay, nice. Takashi and Aoki will play a game of Sugoroku. Takahashi starts at point A and Aoki starts at point B. They're throwing a dice. They're throwing the dice. Dice shows 1 to P with equal probability, and Aoki shows Takahashi has different dice. Wait, 1 to Q with equal probability. When a player at point X throws his dice and it shows Y, he goes to a point which is this. Okay, the first player to reach the point, find the probability that Takahashi wins if he goes first, modulo this. So n is quite small. A and B, P and Q are quite small as well. Okay, why are they quite small though? Okay, Takahashi. It's just DP, right? I mean, are they quite small? Am I not getting? Okay, P and Q are this probability, which is fine. Haven't solved probability tests in a while. Let me just think about this. Am I getting the task right? So there is a int a, b. Okay, so they're all integers. A, b, b, and q. Let me maybe read point F. We have a grid. Let denote this for each integer from 1 to n. A positive integer xi is written. Okay. On the other 10 to the 18 minus s squares. Okay, okay, for the other 0 is written. You choose a square RC and compute the sum s of the integers written that share the column or row. Find the maximum possible value of s. Okay, so you kind of wanna find a point where a lot of these. Okay, so what can we do? What can we do? Sparse. So for each column, if I know where that is, right? This is a much better problem. Just see. So there are some things here, some rooks. Do I have something else? And each of them are on some column, right? Maybe multiple on some column. And then you have each of them are on some row as well. So I claim that the intersections between these two things are what we're after, right? So let's say that the best intersection would be to find the column with the maximum of these, right? And the row with the maximum of these. Can RC be so it's like, okay, so now this problem gets a little bit harder. If it was like this, okay, we would find this intersection, but for each of these there is an integer written. But still, what does it have to do? Can we just have a map and just like this, the biggest sum will be somewhere here and the biggest sum would be somewhere here, right? Now the one problem is that there would be an integer here written which will count twice. That's not good. That's not good at all. Okay. How do we get past this? So if I fix a column, So if I fix this column, right, how can I query very fast on what row? So except here, so I can query on what row we have like this. Okay, there are at most n of these. So I will delete all of these here from each row when I'm going to query about the column. Then I'm going to re-add them. Okay, let's see how we're gonna do that. I have no idea, I haven't planned that far, but I think it's possible. So there is n of these, and then each of these are some. Do we need to store them? Is it needed to be storing them? Probably not, right? So here the thing is that, yeah, I don't know, let's store them. Let's store them in some structure. So like, just to make our life easier. I always do this because it's quite easier to get through, and then I can just go over and say points at I dot read, just call read function and we'll read them. Okay, so first what we said is we're going to go through, let's say we're going through the rows, right? Doesn't probably really matter. And for each of these rows, I will take this thing here, so rows and columns. Okay, and then rows at points at I dot R. At this row, we have the ith column with the ith point. Actually, there should be a vector here. At this column, we have the ith point, right? Let me just do the answer here is 0. And we're going to go through each of the rows. We're going to go through each of the rows, deleting the points from the data structure. Deleting these points from the data structure. If this row has some sum of points that we're looking at, so okay, so let's do this. For each row, we are going to have some sum, row sum at points I at R dot plus equal points at I dot X. So we're going to deleting this from there. Now we need to find really fast a column which is, when we delete these points, how do we manage this? So the answer is going to be a maximum of the answer, row sum at IT first, plus best call, get best call. Now this, I don't know how to do it. I mean, okay, let's think about this. So we have some row. Let's say that we do this row. We go through the points. What we need is what do we exactly need here? For each of the columns, we need some segmentry, right? For each of the columns, I will delete this, and I want to find a column which is the maximum, right? So what about just using a sec tree? Sparse lazy sec tree will do the job. Just I need to modify a few things here. Okay, we're not going to generate the tree. The query is going to be the maximum. I will want to, yeah, so I will have like this node sec tree is node, and this will be on some huge range. Right. Then in the sec tree, I will add, so the value first is 0, right? So the value is 0. The adding function, okay, this should work. So I will first add on the whole seg on what I will for each column. For this column, points I at C, points I at C plus 1, I will add points I at X, right? Now I will delete, so for each element in the second thing, I will delete from the point, so points at element, I will delete the X. Also, I have to bring back the X afterwards, and the best column is sectree.query on all of them, right? Okay, this works. Just submit. Okay, so let's just take a look at task G and EX before we're solving E, because like I'm not really sure about E. 35 minutes in the contest. Why is it so slow? Strawberry war. Come on, what is going on? Okay, E. is what I'm thinking is like, okay, what is the probability of so until everyone is at the end. Oh, we got the wrong answer. Okay, what's wrong here? Can I actually do that? Can I? Yeah, here I'm doing on only 1 point update, so the point update should be fine. I'll see how is this. Wrong answer. Is it overflowing? Oh, it's overflowing. Oh, this is hilarious. This is hilarious. Okay. This is why I should have my tree instead of this. But this already. Just see every integer here. Infinity is 10 to the 18 probably. Okay, LL, so like integer. Here we could, oh, instead of like setting here, I don't really need to set it here. I mean, these are enough to be integers. This enough to be integer, this enough to be integer, this here I'm not setting it, this here, this is fine, this here is fine. These are supposed to be integers. This is supposed to be integer. This is. Okay, I think it's fine. I think it's fine here. Maybe the infinity should be a little bit bigger than this. I don't know how actually bigger than this. What? What? Internal server error. Okay, whatever. This however is like, okay, if I have like a time step solution, so okay, let me just read this here. Maybe we have a rectangular, it is partitioned, has Sij strawberries on it. You will make t cuts to divide into t+1 pieces. Each cut can be done in the following 2 matters. Okay, let me just submit. Okay, what? Excuse me? What's going on? choose an existing piece with 2 or more rows of section and cut along the boundaries to divide them, okay? Or this. You want to distribute the strawberries and onto the resulting pieces as evenly as possible. The width and height are very small. Huh, weird problem. Width and height are very small, which means like how big is that? 36, right? But 36, right? And then you would is it maybe some kind of brute force? And now it will pass. I mean, it was just the long sort of. This is kind of interesting. Find the minimum possible. This is a very interesting problem. I wonder what it uses. Okay, we're given 3 with 10 vertices. The vertices are numbered. Okay, let D denote the distance. Here the distance between x and y is a number. Okay, yeah. Answer Q queries in order. The ith query is as follows. You're given Li integers. Find the sum of the minimum of the distances from some node J, some node R. Okay, this is a problem for me. This is a graph theory problem. Okay, F gets accepted, and I'm down places. Okay, this is for me problem here. The sum of minimum lengths. So what does that mean? What does that mean in like? So that could be some kind of centroid decomposition, couldn't it be? But the sum of minimum of these 2 lengths. So let's see if L and R are like in the diameter. I mean, it's not the easy problem. The distance between. I'm not sure. Let's solve the easier problems first. Okay, so unfair Subaru. This should be a straightforward probability problem. If I have like the probability of Takahashi winning, what is the probability of so we have some places, right? And we want, so it's Takahashi is here, let's say Oki is here, and they can all throw like a ball here. The probability. So if I say, okay, if I have 2 arrays, which is where is now Takahashi and where is now Aoki? First it would be like this, right? Then after one move, what is the probability of Takahashi getting here? It's like 0. Let's say 0 0.24, 0 0.24, 0 0.24, and 0 0.24. 25. They can be in the same place, right? Yeah, they probably can say it can be in the same place, right? Then Aoki just does that, right? And if Aoki does that, let's say 25, 25, 25, or even like reaches here with some probability, so this probability, Aoki wins at like the first game, right? With some of these, like this probability. Okay. All right. And how does this affect the future development? It affects it with this some kind of probability. Takahashi will lose, and now everything is 1 minus this. Maybe that's correct. Let's try coding this quite quickly. So we have like two arrays which are of length n, right? I mean, yeah, like why not like this? Okay, and then dp of, so a is dp of a is dp of 0, a is 1, dp of 1, b is 1, and then it takes turns. And if turns are this, it's Takahashi, else it's Aoki. Okay, so we have P and Q, right? We find the next probability by taking a look at every probability which is here. So like from 0 to n, right? Yeah, so 0 to n. If there is probability, if so, like for each of these, I will go for each of, so if dp of 0 of I is so I will go like this from 1 to p, and then the resulting point is the minimum of I plus p and n, right? And then the dp of the new dp of the result plus equals the my dp of 0 I divided by p. This is what the new dp will look like. And then we can like swap dp of 0 dots dp of 0 dot swap new dp. We could do this. Okay, and then so the terms are at most 2n. This is n and this is at most 10. Which we're fine. But there is one thing here. There is one thing that like now I have to say what is my answer and what is my coefficient before the answer. For now my coefficient is 1. Okay, so what is the probability after these steps that we get there? Coefficient is 1 minus the probability at 10, and answer is like plus . Is this correct though? I'm not sure. And the thing is that like this would be similar with IOK, but now here it's going to be 1, here is going to be 2. So we're going to do this, the same idea here. Now the answer will not change, but the coefficient will. Yeah, at the end it's just like the answer printed. I shouldn't work, because I probably missed something. Oh, and yeah, the turns is like, have we actually gotten anything here? So has the answer actually changed? So actually turns is like enough to be like 2n plus something. Yeah, that's not the probability. Definitely that's not the probability. Oh yeah, here we want the coefficient times this. I mean, what are we missing now? Does it change if I make more turns? No, it shouldn't change. This should be enough. So the coefficient is like, okay, I went there that many times, and then 1 minus this is like oh, we need to lose. Oh, well, here when we lose, well, yeah, we'll lose by the coefficient, right? Let's see the standings here. We'll lose by the coefficient, don't we? Can I print out the DP here? Such a shitty test. Yeah. Yeah, I mean, go figure why is this the case though? Go figure. So for each n, we just distribute this. And we want only to, if I finish here with some probability, it means that every game afterwards I have this coefficient on mind, right? Do I multiply or do I add to this coefficient something? No, wait. Every game afterwards so if I have probability of 0.2 winning here, right, then 0.8 is what I'm getting afterwards, right? But yeah, the problem is that like both of them yeah, you can't have like, you can't have this because you will need to have like a state which is like n times n like matrix, which will denote the probability of all of these happening to be in like, yeah, it's wrong representation of the DP. You have n by n matrix which has like this probability of like A and B first here, but this is one. Then you somehow divide this probability over into where this can be by trying to see if yeah, but like this, dividing this probability over here. But first this is Takahashi, so Takahashi will divide this probability over to some area, right? And then from these areas, Aoki will divide the probability to over new areas. So this will be n squared times n. Here the division of probabilities, right? Is that correct? Yeah, times 2n. Yeah, let's try this. So there's like n by n matrix. And the DP first, the probability is at A and at B is 1. And there's the answer. I don't know about the do we gonna need a coefficient though? Maybe, I don't know. I'll think about this. Okay, so the terms is the following. So Takahashi divides first the probability, and it will still create a new n by n matrix. like this. New DP. This n by n matrix, for each of these n by n, I will take this, and so for each ij till the end, right? I will take this probability and I will say that, okay, the resultant probability is I'm moving res I, res j. Res j will be equal to j because I'm not going to move IOK anywhere. I'm just going to move the Kahashi. And it's going to move plus I plus p and then n, right? Si Sj is going to be our dp of ij divided by p. This whole thing is the same. So what is going to be the answer? The answer is going to be the sum where I ends up in n. So it's like the coefficient times, like here the sum is where j goes through 0 through n. Like this. The sum is this. The coefficient then gets smaller, and then we reset the new. We say that this is 0, and then we swap this. And this should be the same idea here. But here IOK is a bit different. This here changes. This will change. This will change. This here changes. This here is not introduced. This here changes as well. Does it pass? No. Huh. Why is this so? This is n times p, which is correct, and then times n. So it's like 200 times 100 times 100 times 10. What if I add more? Will it change the answer? No, it doesn't change the answer. Yeah, which we can prove that 2 times n is enough. But what is the limit on this problem? Oops. 2 seconds. They should pass. They should. This is like. Like this is 1,000. Although, yeah, memory allocation here is slow. Yeah, memory allocation here is pretty slow, isn't it? But still, this is slow. Let's see in, I mean, it's not even correct, but should be. Two seconds. 2 seconds. Yeah, this is like this, and then the sum is kind of changes the coefficient, right? Or does it? I don't know. Should I change the coefficient? Okay, so this is correct without any coefficients whatsoever. But I don't know if this is in the time limit though. I'm really afraid because it's just really close to the time limit. I don't know how to optimize this. But if I change like I can't do shit now. Let's just try. Maybe it will pass. See how fast their servers are. I was afraid of that. It's probably like time limit on just like 2 or 3 cases. If I don't swap, what can I do? But swap is not expensive operation. Although yeah, just 2 cases, time limit exceeded, okay, whatever, just 3 cases. One in the I mean, it won't tell me how much my time limit exceeded. Just like 2.2 seconds. Would it make a difference if the vectors were like if it weren't like a vectors but it would be array? Would this kind of make difference? It doesn't make that difference. I don't actually need this as well, right? I only need like a row here or a column. Still, does that really take that much? No, it's like the iteration of this here. What if I say that, okay, if there's zeros, if they're all zeros, if dp of ij is 0, then we just continue here. And here, how fast is this? This is pretty fast. Okay. This is pretty fast. I mean, the time limit shouldn't be that okay, so I wanna maybe, what should I solve here now? G or EX? Okay, gets accepted. Let's just take a look at the standings. I'm not sure what should I solve here. Probably try to solve EX or something. This should be like straightforward brute force problem. I'm not. Due to ongoing impact of the DDoS and the continued difficulty in accessing the site, the contents will be unrated. Really? Somebody DDoSing it? Come on, man. I don't know how to represent this. I want to see this here. Maybe it's some kind of data structure that it's easy to build in 20 minutes. So let's, come on, like, who DDoSes AtCoder? This is insane. They should keep it rated. I don't know why. Whatever. Okay. The minimum of the distances between L and R. So if I say about the minimum, each centroid has some nodes which has the minimum distance to, right, from other centroid on its level. Okay. So this centroid is like the minimum distance to some, like, to nodes inside. Then you have another centroid. And so what you want to find? You want to find given two vertices, find the sum through every other vertex. Okay, so let's think about this like a centroid decomposition problem, maybe. I don't know. So you have some centroid which has some kind of area, right? And then there is another centroid here which has some kind of area, and then they are some kind of combined on the top level here, like that. This is some kind of, this is like the centroid tree. It's not the tree itself. But so from this, what we know, that if I pick a node, let's say I pick a node, let's say I pick this centroid and this centroid on the same depth. What does this, what is this telling us? This is telling me that some nodes in this centroid have minimum distance to this node, and the nodes in this centroid have minimum distance to this node. And then this node it's actually hard. It's I mean, yeah, you have to keep track on top of this as well, right? But I'm sure it is centroid decomposition here. If they're not on the same level, it means that here there are multiple, there is like a bigger level. Then what happens here? What happens? In this level, It's difficult. It's like this DFS out here where you're going click up here. I need to solve this problem, but like as an upsolve probably. There was a gem-century decomposition something. Maybe there is a similar problem. There is some gem here. I just don't know how to find it. Actually, in the video, does it have like a gem? So I don't know. I don't know. I haven't really worked with century decomposition before. I know like what's the idea, but I don't know like this is the minimum thing here. It's quite a complex thing for sure. This minimum even if you have century decomposition, how do you find this? take a look at like this though. Let's assume that we have like some subtree here. Let's assume that here is the LCA. Let's assume that here there is like no, and here there's like subtree, such like this. And let's assume that this node is like in between these two nodes. So this is L and R. Or R and L, whatever. This node, let's say it's the middle. Then what happens here? Let's say that there are two nodes. So that this edge, this path is like odd. Or like even. It's like even. From L to R is like even. So the distance from L to R is this, right? Then in this whole subtree, everything is closer to L, and in this whole subtree, everything is closer to R. So the only thing I need to do is like cut the subtree and then like have somehow compute this. If it's even, it's a little bit more. If this length is even, it's a little bit more difficult to really, like, you would have like, for all of these nodes, these are closer to L, let's say, and then for all of like these nodes, they're closer to R, as like a bit more difficult, I would say, or just maybe it's not a little. It's not maybe difficult. It's maybe just you're overcounting one node and just. But essentially, we can divide the problem like this. Now, given this subtree, given some subtree and a node in the subtree, what is the sum of the distances between every node in this subtree? So every node in subtree S and this node L. This is what I'm thinking. And this kind of looks like a split, like a cut tree can I mean, it kind of looks that it's possible. Link cut. Okay, so how do we solve this? Given some subtree, tell me the sum for all distances. I mean, we can have like maybe heavy light decomposition for each node here. I can remember the subtree size of this node minus this, like some kind of a heavy light here, but no, it's like you would have like branches. So the idea here is what? The idea is to what if L was a root? That would be easy. Still requiring. Still, I think you could get away with like century decomposition, and then I don't get how else would you approach this distances problem. I don't know. Let's recap all the problems, and then we are going to read the tutorial. Hopefully this ends soon. Okay, so first problem was just to find if these two. So you had to find if there is at least one good impression and no bad impressions. And you just check this. If that was true, then it's yes, otherwise no. Pretty straightforward. Here you had to rotate the matrix 90 degrees, and by rotating the matrix 90 degrees you had to check if there exists something on AI, then Bij had to be 0 and had to be 1 as well, right? And this is like just implication. If this exists, this has to exist. Otherwise, if this exists and this doesn't exist, so it's like contradiction, then it's false. Rotating the matrix, I already have this like snippet here, which does the rotation in like of n squared, so like the size of the matrix, without the usage of so yeah, that's just straightforward. You just increment one of the column and get the row reversed, and it's just straightforward. I don't know if it rotates it like clockwise or counterclockwise, but still it's a nice snippet to have. So I don't have to write this all the time. It does do this, and it just outputs this result matrix. Yeah, the other thing is this C problem. The problem C was about having like some cards and some boxes, and inside some boxes you could put multiple, like you could write an integer on some card and put it in a box. But in a box you could have multiple cards with the same integer, but you had to all print out as well, like for each integer, in what boxes is it seen. So this contain is like I is contained inside the box J, right? But here you only count the box once. So that's why it's like here it's like multiset and here is set. And like the assertion is here log n, because you had to print them in ascending order. So the set is always keeping, and multiset is always keeping them in an ascending order, in a sorted order, sorted ascending order. Here D is like, it's like pretty straightforward problem. I'm just having a Q here and S, some like number S, and this S will always be under the modulo, and the Q will be like the Q of digits, so like just characters here is an output, whatever. And the one operation is that you can add a digit at the behind of this, and what this does to S is just times 10. It shifts S times 10, and then it adds the digit. But because it's times and plus, these two operations under modulo, under this prime modulo, can be under any modulo that they can be done. So it doesn't actually have to be a prime module. You just do like s times 10 modulo something, modulo this number, right? And then for the digit as well. So I have this struct here, which does these things for me. Actually, thanks to a Slovenian colleague, Benjamin Byte, I actually copied from him this struct. It's pretty good, I would say. And this here is like I'm just adding to the queue on the behind like a digit, and then when I want to erase this first number, what actually I need to do is I need to erase from S from as much as the first number weights times 10 to the whatever the queue is long. Now this here I'm doing it in like logarithmic time of the size of the queue, which is still possible. It is even more possible to have this here pre-computed as another variable, which you're gonna, when you push to the queue, you're just gonna add times 10 to this variable, and when you subtract to the queue, you're just going to divide by 10. This is as well possible if this is possible only if the modulo is prime. It won't be possible, a division is not possible under modulo that is not prime. Also, also you pop from the queue, and then you just print S every time in query 3, in type of query 3. This here, the probability problem, unfair. So what is this called is like, if you have two variables that are like somewhere moving, you just want to create a matrix which keeps track what if like this variable is in this position, what if this variable is in this position. And then this is like the probability that the variables are there. And when it's the turn of one of the guys of Takahashi, you are changing Takahashi's probability. And then you want to find out the probability that Takahashi ends at position n. So like the Aoki, we don't care about Aoki. That's why we iterate over all of the positions of Aoki. Okay? And then there's another thing is that if it's a Aoki, you just want to do this, but kind of don't care here about the sum. I just reset it here. Don't care about the sum. And this is like n, because 2 times n times n times n, so this is n cubic times p times the maximum of p or q, which is still inside the time limit. I just only had this here that like if it's 0, I don't even go here and I save many operations. I make it like 10 times faster, or like 5, 6 times faster. The rook problem. The rook problem was a straightforward problem. So this is what we talked about. We don't want to have something duplicate. That's why in one of the dimensions I just go through the rows, and then in each row I have some rooks, right? And I take these rooks and I erase them from the segment tree of the columns. So the segment tree represents the sum of the columns, the sum of each column. And then when I erase them, I then query what is the maximum column. And then I add them back. But this operation is amortized of n in the terms of the rooks, because there are at most n rooks that I will add here and I will delete here. So it's like n log n, and this is log n for each row, which is n log n, and this everything is n log n. And yeah, that's pretty straightforward as well. So let's take a look at the solution for this problem, because I'm really interested. So yeah, so as we said, the distances between L and R divided by 2 towards the root, and then you have to keep up with the two values, the sum of over all vertices J contained in this, and the sum of these. You have to find the sum of these two. Yeah, but how do we do this? We describe how to find the former. The latter can also be found as a small tweak. Okay, let the J be an arbitrary vertex. Let the V be an LCA of J and R. Then the distance between J and R is the depth of R, yes. Thus fixing V and considering the sum of J R over vertices R can be written as S times depth of R minus the depth of V plus the sum of depth of J. Consider the specific value of S. If V is R, then S is proper implementation. I will take a look at this. I will rediscover these formulas by myself to know exactly what they're talking about here, and how I can actually, like, the values so far can be found if we know M. By pre-calculating the sum of depth U over vertices U in the root as substrate of V. Oh no, I will take a look at this. What about G? As dynamic programming, but with what kind of state? It's a huge state, right? IJ, yeah, into M pieces. So it's like, wow, 5-dimensional dynamic programming. Okay. And this is the whole thing. Wow, that's insane. That's insane. That's insane. Okay. Whatever. Yeah, we'll try to solve this one. Let's see rook score if it had like a better way of doing this. So it's just they didn't even use, they compressed it. They went over the columns probably. Okay, I mean, yeah, fine. Yeah, I see how it's done. Published in 24 hours. A to E into... What is this overall tutorial? Video isn't available. Published in 24 hours. Okay, so thank you guys so much for watching. Please check out the other videos on square root decomposition on trees, other videos on my channel. And yeah, I see you next week.